Today we will learn how to add and subtract unlike fractions. I'm going to do two examples with the visual aid with the little blocks, and then we are going to go do some more complex examples. Let's say I want to add 2/3 and 1/6. As you see, the denominators are different. So these are unlike fractions. So let's color these. 2/3 is, here is 1, here is 2, 2/3. And then when you add 1/6 to it, here's 1/6. What are you going to end up having? Now I have these pieces in different sizes, okay? And when I add 2/3 and 1/6, what I want to do, I want to have a common ground. So I usually, you know the steps, I usually end up finding the lowest common multiple of 3 and 6, which happens to be 6. Alright, so I need to have the first one, 2/3, as a fraction, equivalent fraction with denominator 6. How can I do that? I can do that by dividing each piece into 2. And that is equivalent to doing this. So I have 1, 2, 3, 4, 5 of those. So the answer is 5, 6. Okay? So when you do it algebraically, what you do, you go and you find the lowest common multiple of the first one and the second one, and then you find those magic numbers that you need to multiply them with to get to this lowest common multiple. Let's do a subtraction example. Let's say I want to subtract 2/3 minus 1/6. How do I do that? 2/3 again. Here we go. 1, 2. And 1/6 is like that. So I have 2/3 minus 1/6. Now these pieces are different sizes again. Here's this size and here's that size. I need to match them. One way to match, just like before, I can cut the top one into these pieces and think of 2/3 as 4/6 instead of 2/3, because I have 1, 2, 3, 4 out of 6 pieces, and subtract 1 out of it. Remember how we used to do that? Just subtract 1, just take 1 out. What are you going to have? You're going to end up with 3 pieces, 1, 2, 3 out of 6, which happens to be 3 divided by 3 is 1, 6 divided by 3 is 2, 1/2. Alright, so we actually did this example with the visual aid. Now we're going to go do some more examples where you can actually do the same thing, but it takes a lot of drawing. So I'm going to leave that up to you. Okay, now let's say I want to add 7/264 and 11/36. In the previous video, the C3, we learned how to take the LCM of 264 and 36. So watch that video to see how that's done. Okay? There we found out that the LCM is simply 792. So I need to get from 264 to 792. And that's 3 times. And I need to get from 36 to 792. That is 22 times. Then I multiply the top, which is 21. The bottom is 792. And then multiply the top again, 242 divided by 792. Leave the denominators alone, just like before. And add 21 and 242, you end up with 263. Okay, let's do another one. A subtraction one. Let's say I have 1 over 36 and I want to take away 2 over 363. So the question is, what's the LCM of 36 and 363? And I did that in the previous video as well. I found that the LCM is simply 4,356. Now, how do I get from 36 to that big number? I need to multiply 121. How do I get from 363 to this number? I need to multiply by 12. Multiply the top, 121 minus 4,356. And when you subtract 24 from 121, you'll get 97 over 4,356. Now, you may be saying, well, you did this with such an ease, but how did you find out these numbers, that 121 and 12? What you can do, one way is the long way. Take this number, your LCM, and divide it with your denominator, and that will give you that magic number. Again, take this number and divide it by this one, that will give you this magic number. But these numbers are big. Isn't there a shortcut? So let me show you a shortcut where you don't have to do all these calculations. Okay, let's assume I want to add 1 over 484 and 3 over 1,430. So that's kind of like really big numbers. I made them big on purpose. So let's prime factor these. 484, 2 242, 2 121, 11 11. So 484 is simply 2 squared, 1 2, 11 squared, 1 2. All right, let's do 1,430 again. 2 715, 5 143, 11 13. So 1,430 is simply 2 times 5 times 11 times 13. So what's my LCM then? I need to look at the common bases. Here's 2 squared and 2. I take the bigger one, 2 squared. That takes care of the 2's. Then I look at the 11's. 11 squared and 11. That takes care of the 11's. If I take the higher exponent, that takes care of that. But I still have 5 and I still have 13. Whatever that number is, it's a big number. Let's say, actually, you can go and calculate it. It's 31,460, but that's not the point right now. The point is, how do I get from 484 to that big number? Here's the magic thing. So 484, so I'm going to write 484 in green here in its prime factor form. It's 2 squared and 11 squared. Right? Now how do I get from this green to this red? You see 2 squares are there already and 11 squares are there already. The only thing I need is then 5 times 13, which happens to be 65. That's the magic number, 65, that you need to put in here to make them the same. Let's do that other one. Again, LCM is 2 squared, 11 squared, 5, and 13. And I'll do that with this color, turquoise. 1,430. That one is 2 times 5 times 11 times 13. Now, look how this works. 13s are there already, okay? So they are taken care of. The 5s are there already. They are taken care of. So what am I missing? I have an extra 11 here. And I have an extra 2 here. 2 and 11. So I need to multiply this bottom one with 2 and 11, which is 22. And that's my magic number. 22. And that's how I find those magic numbers. So let's write the top. 1 times 65 is 65. 3 times 22 is 66. And the denominator is either multiplication, which is 31,460. And then you add the top 131, 31,460. So that can be your shortcut. You can either do it this way or do long division to find those magic numbers in green and turquoise that I put up over there.